In today's lab, we will use gas chromatography to investigate vapor pressures. This first, smaller syringe will be used to inject our pure liquid samples into the instrument. The first sample we will measure is liquid acetone. To remove contaminants, fill and empty the syringe with the acetone several times before filling it to the 0.3 microliter mark. Carefully insert the tip of the syringe into the injection port on the front of the instrument. It is important that you click Run on the computer at the same time as you depress the syringe to inject the sample. If they are not done at the same time, the recorded retention time will not be accurate. As you can see, there are 2 detectors on this instrument, as there are 2 injection ports. We are interested in the top line on the screen. When the injected acetone reaches the detector, we will see an increase in the voltage reading. Once the voltage returns to the baseline reading, we can stop the trial. This brings the final chromatogram and information table up. The second liquid we are measuring today is chloroform, and we will follow the same steps as with the acetone. We are again watching the top line for a voltage increase. The time at which the voltage peaks is considered the retention time, and you will notice the chloroform has a longer retention time than the acetone did. Information included in the output data table are retention time, peak area, and peak height. Now we are moving on to vapor phase measurements, which will require a larger syringe to be used. We have a flask with a small volume of acetone in the bottom and a rubber septum sealing the vapor in. The syringe is used to pierce the septum and filled with the vapor. The tip of the syringe is carefully inserted into the injection port of the instrument, and at the same time the vapor is injected into the instrument, we click Run on the computer. With vapor measurements, we are looking for 2 voltage peaks instead of just 1. The first peak will correspond to the room air present in the syringe, and the second will be our acetone vapor. Note that the acetone vapor has the same retention time as the liquid sample. The last sample we will be measuring is a mixed vapor sample. Here we have a solution of 2 milliliters of acetone and 3 milliliters of chloroform in the bottom of our flask. We will measure the mixed vapor in the same manner as the acetone vapor. For this trial, we are watching for 3 peaks: the air peak, the acetone peak, and the chloroform peak. Since all 3 substances have different retention times, we will be able to clearly separate and identify the 3 compounds.